our next notebook. This one is on the topic of data processing, and it is where we actually get to train an NMT model. So this is actually my favorite because it's the funnest part. So first of all, before you actually run this notebook, you need to be aware that some of these steps will take quite a long time to run. So I would only recommend to start running this notebook if you have around 2 hours where you can stay at your computer or at least leave it on when it's loading. And I will explain those steps in more detail later on, but just kind of to be aware that you need quite some time for this notebook to load. All right, another important thing is that you might get an error message about needing more RAM, more space. You can ignore it because it should still work in case you do get this notification, because Google Colab has different versions. So the basic level, the Google Colab basic level, offers a few things, but not as many extra features. And the one I'm working with, for example, is Google Colab Pro, as you can see here. So I might be able to extend this RAM, whereas you might not. But just in case you do have it, or maybe also if you have Colab Pro, you can change it yourself. So here you can go on runtime and you can click on changing the runtime. And then down here it says runtime configuration. If you have the option, you can extend it from standard to the extended RAM. And another very important thing that you do need to do, definitely in this notebook, and that anyone can do also without the Pro version, is that you need to change from CPU or from none to GPU. So we need the graphical processor unit so that the notebook can load faster, because in other notebooks, it's kind of a choice if you want to use GPU because it loads quicker in comparison to CPU. But for this one, we actually need GPU because we need more computing power for these codes. And for big NMT models, they are often trained with multiple GPUs even. We obviously have one, we get one from Google Colab. So if you have one notebook open, you can choose one GPU. And that is the one that will be sort of, that's what we'll be working with. But that will work perfectly fine, as you would see. So this notebook is ideally built upon the data planning and collection notebook, where we prepare our data. So if you have done those notebooks before, either at the basic level or at the advanced level, that's perfect, because now you can use your data, and that data that you've prepared, you can use it here to train your own NMT model. If you haven't completed these, one of the two, it results in the same, so you'll have the same data in the end. I would either recommend you to do that, because it's also just fun for you to see how it works and how you can prepare your own data, and where you even start, you know, where you find your data and how you can prepare it. But if you wish to just run through this notebook without using your own prepared data, we have prepared a zip file for you. So we have our repository, our GitHub repository, right? So you can open it in the link here, and in the section NMT training, so this link will lead you straight away here. And in the section, you have the TED data zip file. So if you do not have your previously prepared data, you can download it here. So you click here on download, and then you will have it right here. And as you can see here, we have a few different files. So if you've prepared your own data, you will recognize these files. And if not, then you can use these files right here. So we have different sub-data sets for English and German from the TED 2020 data set that you can use to train the NMT system, to validate the NMT system. That's where we have the development test sets, so the ones ending in dev. And then we have the test sub-data sets, where we can then test the system to translate later on. So these are the 6 sub-data sets that you have either prepared previously or that you can use now. And then up here we have the two source and target model for the sentence piece, so to tokenize, to subword your data. So this is important because we'll be using that in our code as well, and also in the end to actually desubword our data, we'll be using that as well. So either you have prepared your own data in advance and you can use that now, and it should be exactly the same. The names should be exactly the same as these ones, or you can download the zip file and use these data sets. And if you have downloaded this zip file, you would then need to upload these data sets into your Google Drive. So if you have prepared your data previously, you should have a Google Drive folder, ideally called MT Data Preparation, which has all your data in it. And if you do not have that yet, I would recommend to create a folder in your Google Drive, for example called MT Data Preparation, and then upload these files in here so that in the end it looks exactly the same, because this is kind of our starting point. This is what we'll be working with, these files. And once you have that set up, then you can go and work on the notebook. All right, perfect. So now that we have made sure that we have our folder in Google Drive and our correct data, we can go and actually train our own NMT model. All right, perfect. So there is some background information here as well that I would recommend you to read through, because it's really interesting to learn a bit about how this works. So the most important thing that I will explain is that we are using the OpenNMT Pi toolkit, as you can see here, because there are a few toolkits available out there, also from Joey NMT, that are available to kind of easily train your own NMT models. And you will see that there is actually not a lot of code that we need in order to train a model. And this is thanks to this toolkit that we'll be using. And another important thing is that we will be training our NMT model on the state-of-the-art transformer. So the transformer was proposed in 2017, the transformer architecture. And it is attention-based, mostly attention-based. Before there was an RNN architecture, recurrent neural networks, and the transformer one is now the state-of-the-art one. So any competitive NMT models nowadays are trained on the transformer architecture. So this is great because you will be doing the same. You will be using the state-of-the-art architecture to train your own NMT system. So there is some more information here that you're welcome to read up on, and also more information on the transformer as shown in this article. So you're always welcome to read up more about it and to understand more about it. And either you have, in this step, downloaded the data now and uploaded it to your Google Drive, or you already have it in your Google Drive anyways, because then we can start. So what we've done already in the beginning, because I mentioned it, is that we changed the runtime to GPU. So this is the important step that needs to happen. And if you haven't done so, remember to do that. And now what we can do is that we can start installing the OpenNMT Pi package. So this is something that we need to install in order to then call functions that they have prepared for us. So this is pretty great because then we can refer to their functions and their code. So we'll just run the cell, and you will see that a few of these code cells will take a bit longer to load. The easier ones will be quicker because we're using GPU now, but some of them will still take quite some time because we're working with quite a lot of information here, for which we need a lot of computing power. And you will see that these cells might partially take longer to load than in previous notebooks if you've watched some of the previous videos and tested the other notebooks. So as I'd mentioned before, this is all great to have this information here, and you can see at the bottom it says successfully installed the OpenNMT Pi, but we don't need to see it. You can also see on the green tick on the left hand side that it has successfully been run, this code cell. So then we can just click on the cross here because we don't need to have that information in front of us. So now that we've installed the OpenNMT Pi package, we can connect our notebook to Google Drive. If you've done the previous notebooks, you'll already have done the step before as well. You will need to authorize access to your Google Drive, to your Gmail account, so you have to authorize it here. Then you have to select your Gmail account, and at the bottom you have to click Allow, and then it will connect this notebook to your Google Drive, and it will confirm it by saying Drive mounted or mounted at, and then you can work straight away with your Google Drive. And either you will work with the folder that you've created before, or that you have just created now and uploaded your data into that folder. So here we can see mounted, so it's all great. And these are the data sets, like I mentioned before, that you should have in your folder. So that's really important. And now what we can do is we can change the current directory of this notebook straight away to that folder. So right now, the current directory of the notebook would be to your general drive, but we don't need all the other information that you might have in your drive, right? You might have a number of folders that we do not need for this notebook. So what we can do is we can straight away go into that folder. And this is the first step where you have to actively change information in the code cell. So this won't be happening a lot here, maybe just this one. But here you actively have to change the name because maybe you have named your folder differently than I did. So just in case, this has to be changed. So where I say your folder name, you have to actually write your folder name. And mine is called Empty Data Preparation. So make sure it's all spelled correctly, or if not, copy and paste it so that there's no errors. And then you can write that here, okay? The name of your folder. If it's a different name, then you need to choose your name. And if not, you can also rename it Empty Data Preparation, as we did in our previous notebooks. And then we can run this cell. And then it shows here with this first line, we change the directory to that folder. And with this line, we can check what is in that folder. So here we can see, obviously we've also just looked at it in Google Drive, but here we can see that we actually have all our data sets and the sentence piece models in our folder. All right, so if you run this and your folder is empty, then you need to recheck, or if you get an error message, then you need to recheck that you're referring to the correct folder and that you actually have your data saved in that folder. Because from now on, we can refer to these files straight away because this is the directory now that we're working in. So that's really great. All right, perfect. So now that we have connected we're connected to our folder, we can start by creating a configuration file. So this configuration file will contain all the information that will be necessary to train the NMT model. So within this file, we will store a lot of information that will now go into detail. And then just by calling this file, and the model can train based on the information that is in that file. So this is a really important step. And here I have defined a lot of parameters just to know kind of what they stand for. Once again, you might get this message asking whether you're a robot. So you just have to say, I'm not a robot. I will quickly show you the code set and then go back up here again to talk about some of the specifics, because oftentimes you might find, if you want to train NMT models and you're looking for information online, you might find information like this, but you might not be able to interpret the information. So we're trying to explain that here in a bit more detail, at least enough to be able to understand what we're working with and what's important that we're working with. So you do not have to change anything in these cells, okay? So preferably do not change any of it, because this way it should work perfectly. So this long cell block is the one that creates where the configuration file is created, and it basically just saves all of this information. So everything that's written in here will be saved in the configuration file. And in case you know a bit about coding before already, the hashtag before is a comment. So anything that's written with a hashtag before is a comment. So that's not information for the, that's no coding information, that's information for us to read. So everything without a comment, without a hashtag before, that's the actual information that the computer will read. Okay, so I have explained these parameters in text here, so you can read through them, and I will explain them as we read, as we go down here, step by step. So this is the step where we're talking, okay, we're going to create a configuration file. It's always called a config. It's a YAML file. And we are working in our folder in Google Drive. So we are working in this empty data preparation folder. So this config file will be saved in that folder. But then within our empty data preparation folder, we will create a new folder, and that folder is called run. So this is where we're going to save some of the data that we'll be working with. And then here we are referring to our training files. Okay, so here we are referring to the training data files, and here we're referring to the validation or the development data sets. And you can see in the front here, this is the path to the source data. So as we said, we're working with English as the source language, and this is the path to the target data. So we're working with German as the target data for our example. So here, this is the train data set for English, and this is the train data set for German that we have created before. And that is why previously I've mentioned that it's really important that the names are exactly the same of the files, because if you have renamed your files, this would have to be renamed as well, because we're calling these names here, we're calling these files. So if you have named them something differently, you would have to rewrite that here. But because I would prefer that no one has to rewrite anything in this code, we are working with the names that we have already received from the data preparation or from downloading the zip file. So these are the training data sets that we're calling here. And then here, these are the validation data sets. So also, once again, we have a path to the source data set. So this is the English development data set. And then we have the path to the target data set. So this is the German development target data set. Okay, so this is the information that we're calling here. We're calling the data sets that we already have, because naturally the system needs to now train on these data sets. If we look down here, we will create vocabulary files. So now in these data sets that we have sentences. So one line is one sentence, but we also need to create vocabulary files that the computer can train on. And I will show below an example of how they look like. And these will be saved. So we will have one file for the source vocab, so for the English one. And this will be saved in the run folder that we will create here. And it will be named source.vocab. And we will also have a target vocab file, also saved in the run folder, called target vocab. And below we can define the vocabulary size, which here we'll define at around 50,000 entries. So this is also a number that can be varied, but this is also the same number that we used for training our sentence piece model in the data preparation step. So it should be the same here. So ideally, this doesn't need to be changed. And then we would just skip a few of these aspects. But the next important one, for example, would be that we are calling our tokenization models as well. So these are the subword models, the sentence piece models that you've trained in the previous notebooks. And once again, here we're calling the source subword model called source model and the target one. So once again, it's really important that the names are the same of the files, because we are referring to the exact names here. And this shows that the model can use these models to train the data on for subwording. Next, we will go to two more things that will be created throughout this process. So once you will get a log file called train.log, this will be saved in the original NMT data preparation notebook as well at the end of the training, because this is where it logs all the training information. And we will analyze that or look at that in a bit more detail later on, but it's a log of the training. So this file will be created after training. And then we will also save, most importantly, our NMT models. So we will be creating a new folder called models in our MT data preparation folder. And the model that will be trained will be called model.friend, and then it will have further information based on which model it is. So with during this process, we will be training a few models, because now we'll just be training our NMT model for around 1 hour. So we could also just save one or maybe two models. But the more you train, the longer you train, it's important to save different models at different time steps, because maybe your computer crashes in the meantime, and if you haven't saved anything in the meantime, then you will not have any saved model at the end, even if your computer has been loading for 10 hours maybe. And at the same time, if you have different models saved, you can test, for example, the performance of different models. So naturally, we will always use the last one that has been saved, because that is the final one that we have trained. But maybe you also want to try and test different steps before that to see, okay, how much has it improved from the step before? So this is not something that we will be doing, and it's not necessary to do, but it is always important to have different models saved at different times. So this is just where they will be saved and how they will be named. And then we won't go into too much detail here, but it's also explained above that it could stop after a few savings in case, this won't be important here because we're only loading it for 1 hour, but sometimes models train for days, for example, and then at one point they might not improve anymore, and there it would lead to something called overfitting, which is unwanted, and then this step would tell the model, the training process, that it can stop training. This is not as relevant for us because we're only training it for 1 hour. And even if you do want to increase the training times, you could still leave this at around a number of 10. So next, this is actually where we save our models. So this is our save checkpoint steps. And it says that every 1,000 steps, we will be saving our models. So if we train it for, let's say, 2,000 steps, then we would have two models. One saved after 1,000 steps and the second one saved after 2,000 steps. If we have 10,000 steps, we would have 10 models saved every 1,000 steps, okay? So we have this at a low number here because we will only train 4,000 steps, as you can see here. We will keep all 4, and usually this number would be a lot higher. So if models are trained 10,000 or maybe 100,000 or even more steps, then we wouldn't need to save a model every 1,000 steps. Then this number would be higher, so that you don't save 100 models, for example. And this is one of the most important steps as well. This is the actual training steps. So as I just mentioned, we will be training a model for 4,000 steps, and this is a very small number. So this is just because we will be training kind of a little demo, an NMT demo model. which will be sufficient enough that we can see that it works and that we can see that the training works and we get an acceptable translation at the end. But in comparison, NMT models are often trained with around 100,000 steps or even more. So for large NMT models, they are trained for days. If you train one for 100,000 steps, that already takes at least 10 hours. So this one, where we train our model for 4,000 steps, will take around 1 hour. And as you see here, we will save steps every 1,000 steps. So we will save a model every 1,000 steps. So we will have 4 models saved in the end. And the last one, the one saved at 4,000, is the one that we will be using to translate, because that will be our final model. And then we have the in-between ones that we have as kind of a backup as well. So that is the training step. Then we also have validation steps. So remember, we have our training data, right? So this is the one that we're working with, but we also have our development data, our validation data sets. So this is what happens here. We're telling the system, every 1,000 steps, please validate my training. So we're training the NMT model on our training data set, but then every 1,000 steps, it is validating this training using our development data set. So this also, we leave it at 1,000 here because we only have 4,000 steps. But once again, if you're training your model for, let's say, 100,000 steps, then you could increase this validation step to 10,000, for example, that you validate your data every 10,000 steps. So naturally, as you change parameters on one side, you also can or should change them for other parameters. Those are pretty much the most important aspects to kind of understand. This is also okay. We're reporting every 100 steps. We will see that below. That's just that we get information. We have some warm-up steps. Here, this shows that we're using a GPU. So this is necessary. This won't work if we don't have GPU. And it says 0 here, but it means 1 because computers start counting at 0. So this is the first index. So we do use 1 GPU. And then below here, I won't go into more detail because this also doesn't really need to be changed much. One thing that I did want to talk about was the learning rate right here. We have set the learning rate here to 1, which is really high in comparison to NMT training because we will only train our model for 1 hour. And that 1 refers to that it trains quite quickly. If you would train your model on 100,000 steps, you could not have this learning rate at 1 because it would be way too high. Because then the model would train way too quickly and then stop very quickly, and it will go back to 0 pretty much, and you wouldn't have any results in the end. So learning rates for big NMT models, ones that you train for 100,000 steps or so, would need to be around 0.002 or 0.0002, which sounds incredibly small. But if you're thinking about the computer training for 10 hours or days, it needs to be in small increments. So this is just the information here that we have 1 as respectively high number, but it works fine for the hour, for the little demo that we're using here. But if you ever do increase the training steps by yourself, this would definitely need to be an aspect that you need to change as well. So kind of to 0.002 or so to make sure that the training works well. So that's a very important step. And then here also we see that we're using the transformer, so the encoder and the decoder. And then there's more information about the transformer that is not as relevant here because we wouldn't need to change them. So obviously you can change per se most of these parameters, depending on what your aim is, depending on what you want to train. But if you want to either use this demo, you don't need to change anything here, or if you want to adapt this demo and train your model for 100,000 steps, you would also not need to change anything here apart from the learning rate. So anything down here you could just leave as it is, which is why we won't go into much detail, because you wouldn't need to change that. The most important things you would need to change are the ones up here where you change the training steps, the validation steps. This is if you want to train your model for longer. But right now, we don't need to change anything. So you don't need to change anything in this code cell. We can just run the code cell to create a configuration file. And you will see that it goes really quickly. So it's merely saving this information in a file. And we can check our folder again to see that now within our folder, we also have our config YAML file. So perfect, it's all worked out. So next, we can actually go and build our vocabulary. So at this point, we are creating our vocabulary files, the ones that we have defined up here. Right now, we've only defined it, but we haven't actually created them. So now we're getting to the step where we're actually creating the vocabulary files. So you can go to the section and just click here on building the vocabulary, and you will see the output. And we're using our configuration file. So here, this is, we're calling from, what we're calling here, the function is from the OpenNMT toolkit. And this refers to our configuration YAML file. So this is the one that we have created just now. And you can see here now, we have the source vocab file of 48,000, so almost 50,000 and entries, and the target one here as well, almost 50,000. And now, potentially, if we do go up here again, we now see the folder run. And within that folder, we have our source and target vocabulary file. We can also look in our actual drive folder. You can reload the page because sometimes it takes a moment. And you can see on the one hand here, we have the configuration file now as well. And we have the run folder, which if you can click on it, you can see the source vocab and the target vocab. So you can either open them here as well, just to have a look at them. Or what we can do in our notebook, we can print the first 5 and the last 5 vocabulary entries. And remember, we're working with subworded data, right? So this is tokenized. And these are the vocabularies of the English of the source file. And you can see it also counts punctuation. So naturally, the most frequent entry is a comma and then a full stop and then the word the. And then to. So this is the occurrences. This shows how often this word occurs. And in German, we have the same. We have a comma, and then we have die und der. So words that, or punctuations that occur very frequently. And then at the bottom, so there's a long list, a 50,000 long list of vocabulary entries that we have saved. And at the end, you can see that we have words that only occur once. So something like inventor or igloo, injured, these are words that only occur once in the data. So that's where this one comes from. And the same in German, something like zuschlafen, auszuradieren, that only occurs once in the data too. And this is just to see kind of how it looks like in the vocabulary files, because this will be used also for NMT training. And you can also look at your vocabulary files by actually opening them in your Google Drive. Perfect. So now we are actually already ready to train our NMT system. And as you can see, we did not need to change anything in this notebook apart from your folder right in the beginning. Ever since, you didn't need to change anything. And now we are actually going to training, which is the fun part. And remember that, so now the data, the files that you have saved, you can use later on as well, technically, but I would recommend to do it all in one go and actually start training. But remember that once you start this, training, it loads for about 1 hour. And it is really important that during that time, the computer stays on. So if it goes into standby mode, for example, the training will likely stop. So if your computer will go into standby mode or turn itself off, or if your internet connection crashes or your computer crashes or something, then the training will stop. So it's really important here that your computer remains on. So either you're on your computer and you're working on something else, it's okay, you can work on something else. So you can, when it loads, you can have this window loading here and then still go into your drive or into your emails and work. So that's not a problem, as long as you leave this open. So you need to leave this open and you need to leave your computer on. I, for example, always have my computer, if I train something, I always have my computer plugged in, and I change the settings of my computer that it never goes into standby mode. So my computer would only go into standby mode if it's not plugged in or if I turn it off. But on its own, if I plug it in, it will never go to standby mode, because then it can train overnight and nothing will crash most of the times. So that is something really important here, that your computer needs to remain on and active for this training to continue. But in this case, it's only 1 hour, so it should be okay. But that's just an important fact for you to know. All right, perfect. So we have our information, we have what we need to train, so we can go ahead and train. And this is done very easily by just this tiny cell here, because everything is given to us by OpenNMT-Pi. So this calls the OpenNMT-Pi train function. So we don't actually have to do anything. We just have to call our own config YAML file. So this file is the one that we have just created and which we can now call for actual training. And that is everything we have to do. Now you just click this cell and it will train. And this is now where kind of the hour starts. And I will explain 1 or 2 aspects as training starts, and then I will pause this video and restart again when the training is over. So this information is all really interesting, but you don't need to understand it all. The important information is at the bottom, but just to kind of give you a quick overview. Here, for example, it says, okay, we're working with a transformer encoder, and then it's calling the embeddings, and there's a lot of architectural information here of like the transformer architecture that we do not need to understand. If you are interested in it, of course, that's very interesting to read about it, as linked in the article above. And you can see it's working with self-attention, as the transformer does. And it's interesting just because by looking at this here, you can see, okay, it is actually, you know, using the transformer architecture and it's all working great. So it's really interesting to see just what it's calling here and what's happening kind of behind the scenes, because this is also, all of this is pre-written for us, you know, this code is prepared. So this is kind of what is happening, what actually behind the scenes during training, but it's nothing that you need to really understand or look at, but it's just interesting to see. And then also we're working with the decoder because information is being encoded and then decoded. So that's just a very interesting aspect. But then we get to the truly interesting information for us. And here we're, for example, working with the vocabulary files that we have created, the source vocabulary files and the target vocabulary files. It's calling that. And then it also says, okay, starting training on GPU with the one GPU. And here now we can see this is our first step. So we have already trained our model 100 steps. And this shows the total. So we will be training our model for 4,000 steps as we've defined. So naturally, if you will train your model for 100,000 steps, this would be 100 of 100,000. So this shows the step that we're currently at and the step that we will be reaching, our final step. And then here, this refers to our accuracy. So how accurate this model already is. And you can see the accuracy goes up to 100. So from 0 to 100. So clearly this is still very low. But you will see that this will increase as training goes by. And another important thing, for example, is our interesting factor is the cross entropy. This value will go down ideally to 0. It won't be at 0, but you will see that it will drop. So already from the first to the second step, you can see that it's dropped. So that is good. We want the cross entropy to be as low as possible. And you can see here as well, the accuracy is already at 12. So it has increased. So we want the accuracy to be as high as possible. In the beginning, these steps, these incremental steps will be more noticeable, bigger. And then in the end, as training goes on, the increments will be smaller. So you might only have an accuracy increase of 0.1. So now this is the step that will take around 1 hour. So here is our first step, here's the second step. So now we will simply wait until this is done. So the most important thing is that this needs to, stay like this. So do not pause it here, do not close this window or shut down your computer or even let it go into standby. Just leave your computer on and loading on its own, because now there's nothing you need to do in the meantime. And like I said, you can change the window, you can go somewhere else, you can, work with whatever else you need to work. And you can see that if it's gray here, it's loading. Sometimes maybe you might get an error message and then it would be red, but as long as it's still loading, it should be fine, just as a warning in case that happens, because sometimes the computer, the color interface, things, maybe you're not there anymore or something, and it kind of thinks it's stopped, but it actually keeps loading. So just as a heads up. But nothing should happen in the meantime. It should be all safe for you to just leave it on like this. And I will pause the video here and come back to in an hour, when the model has done training. All right, welcome back. I paused this video as long as this model was loading, so for the last hour. And you can see actually down here, it was loading for exactly 1 hour and 6 minutes. So it should be around the same if you're loading it on your computer. And as we can see here, our final checkpoint, our final model has been successfully saved, and it should be saved in the folder models under the name Model Friends Step 4000. So we will look at that in just a moment, but just to kind of recap, this is the training process, which you should also be seeing on your screen. The values might be a little different, so if you have a different accuracy or something, don't worry, as long as it's increasing with training time. But if it's not the same, it's fine, because the models will be training a little differently each time we train them. But as you can see here, we have the first step from the 4000, and it keeps going on until the last step that we trained, step 4000 of 4000. So that's really great. It's all worked fine, just as we wanted it to. And we can see, as we talked about earlier, the accuracy started with around 6, and it increases, as you can see, quite noticeably in the beginning. So quickly increases here the accuracy. And here you can see it increases a bit slower already. So remember, I told you that in the beginning, the steps will increase more noticeably than in the end. And then we actually finish with an accuracy of 75.8. So that's quite all right if you think about the fact that we've only trained this model for 1 hour. We have quite a high accuracy, so we should definitely be getting quite an acceptable translation from this. And what I also talked about in the beginning, remember we were talking about the cross entropy. So here we started with this is not the top. Here we started with a cross entropy of 9.5. And then it slowly or quickly drops in the beginning, and then it drops a bit slower. You can see here also drops a bit slower, but it still drops. So that's really good. And we finished with a cross entropy of around 2.4. So this is acceptable as well. The lower, the better, naturally. And if you train longer, bigger models, it will be lower. But these values should be acceptable. And another thing that we can look at is the validation in between. So we said we want validation steps to happen every 1,000 steps, right? So we can see here, okay, we trained 1,000 steps, and then it says here validation stats calculation. So this part here is now validating, and it's also talking about the validation perplexity, accuracy, and then after it has validated, it saves the first checkpoint. So here we can see this is the first model it saved, model step 1000. And then it keeps training and it starts with step 1100. And we go and we train for 1,000 steps. Then we reach 2000. So again, we do validation. And again, we save our checkpoint. Now it's called the step 2000. All right. And then we keep training. And then we reach 3000. And then we have a validation again. And then we save our checkpoint again. So now here we save the checkpoint 3000. And then once more we train until we reach step 4000. And then we validate again. And then the final checkpoint saved is the model 4000. So this is because we decided that we want to train the model with 4000 steps and validate it every 1,000 steps, save the model every 1,000 steps. So naturally, if you have different values here at one point because you want to train a bigger model, then these values will be different. You know, you might train a model for 10,000 steps or 100,000 steps, and then you would validate it at different sections or save the checkpoints at different steps. But this is what we've decided in the beginning, and that's exactly what the model did. So that's perfect. So this is what it says here, that we have saved these models, so that's great. But we want to just make sure that they're actually there, right? So they should have automatically been saved to our drive folder as we defined initially. So we can go back into a drive folder and we can see straight away here, now we have a folder called models. So you can also reload your page if you can't see it yet. And when you click on it, here we can see we have a 4 model saved. So this is the one of 1000 from the first checkpoint, second model, third one, and the last one. So this last one is the one that we want to be working with because that is the kind of final NMT model, the best that we have trained, right? The other thing I was talking about, remember in the beginning we talked about the train log. So we go back to the configuration file and I mentioned that I will be talking about the log file. So we saved our log file, right? The train log. And what we actually save there is all of this information. So everything you see right here, the architecture and everything, the structure of the model and all the steps and the values of the accuracy and everything, that information is what is saved in the train file, in the log file. And this is also saved here on Google Drive. So this is exactly, if you open it, you can look at it. This is the information that we have just looked at. All right? And that saved all that content. So just for you to know that this information isn't lost. It's for example, if you close this notebook afterwards, that information is still there. If, for example, later on you want to look at the accuracy, you can look at it on the log file. So perfect. That's all about training the NMT model. You have now successfully trained your own NMT model, and now we can actually use this model to translate and to test how well this model has been trained. So the one that we will be working with is the last one that we saved, right? The one in step 4000. And now we can use this in our translation step. And remember in the beginning, we divided our data sets into sub data sets, where we had the train data set and the development data set and the test data set. So this test data set is the one that we'll be working with now, the English test data set, because this is the one that now we can translate. Because remember, we trained the model to translate from English into German. So now we can submit this English test set, and then we should be getting a German translation based on our NMT model. Okay? So what we can do is we can just go to this section where we can click on Translate. And once again, it's very simple. We call the OpenNMT function from their toolkit, and then we refer to our model, the final model. So here, of course, you could also test model step 3000, for example, and that should give you a worse translation in comparison. The final one should give you the best translation. And then here it's asking for the source text. So the English test file, that is the source, that is what we want to translate. And here we define the output translation. So this is what we will receive, right? So our final file will merely be called translation. This could be renamed differently, but we name it just translation. And then here it also refers to the fact that we're using one GPU. And these are some other factors. This refers to the fact that it should be printing something. I won't go, so to avoid empty translations, but I won't go into much detail. And this verbose refers to the fact that as we run the cell now, it will print the translation for us. If you do not wish to see that, you can delete this because it's not necessary. This is just to see that while it's loading, we can actually see what is happening and what we're getting as an output. But that's all you need to know. So of course, if you have renamed your file, you need to submit your name, but I'm hoping that you haven't done so, and then you wouldn't need to change anything here, and you can just run the cell and it will automatically load, and we should be getting a German translation as an output. And you can see down here, the rows change quite quickly because now it adds, but you can see on the top line, it will always be the English sentence, so the input, and on the bottom line, you will see the German. And as you can see, the output is subworded because we're working with subworded data, right? So the test set is subworded from a previous step, and we train the model to work with subworded data. So the output is also subworded. So you can still see the underscore. And we will desubword it in just a moment. But you can see it's working perfectly fine. So this information down here, if you deleted this verbose, you wouldn't see this. But I find it quite interesting to see because you can see straight away that it is working, that you are getting a translation. And this will also take quite a moment. So the test data set, if you remember, we have 35,000 lines. So naturally, here we are at 3,000 now, almost. So it will take quite a moment to translate all of this as well. So I will pause this video again, and we will come back to talk about the translation once it's done translating. So, perfect. As you can see now, this cell has stopped loading, and it took around 14 minutes. You can see it here on the side and also down here to translate the complete English test data set. And you can also see because now it's stopped running. So now we can actually take a moment and look at this translation. And so this is the last sentence, the last segment of the data set, as you can see, 35,000. And this is one English sentence. When I was in college, my senior year, I took a course called European Intellectual History. And then this is the German translation from our model. Als ich in der Uni war, nahm ich einen Kurs namens Europäischen Intellektuelle. So if you do speak German, you can see it's not perfect, but it's quite acceptable. You might have a different sentence here, because if you have prepared the data yourself, you most likely will have a different sentence. I'm sorry. Because if you have prepared your data yourself, or if you have downloaded the ones I uploaded, which I didn't use in the zip file, the data will be shuffled differently. So you will have a different row than I will, a different order of these sentences. You will have the same sentences, so the same 35,000 sentences, but just in a different order. So if it looks different on your screen, don't worry. because it will be the same content but just shuffled differently, okay? But as you can see, it has worked, and the translations are pretty acceptable. They are full sentences, and you can actually understand the content. So you can see that our model performs quite well, actually, especially considering we've only trained it for 1 hour, which in comparison is nothing. So it has trained really well. There's one thing I wanted to show you. So first of all, we can see that this is still the subworded data, right? The tokenized data with the underscores. We will get rid of that in a moment, so don't worry for now. But there is one thing I wanted to show you, that in case you have a sentence where it says unknown, that means that for that translation, the model didn't know what to translate. So there shouldn't be many, but I saw one as I was training earlier. And just in case you see that, that just means that there the model didn't know how to translate a certain input word. So it prints out an unknown. But I can't find one right now, which is a good sign. So there aren't many, but I saw one at the top earlier. So just in case you see it, don't worry, because that's obviously because this model isn't perfectly trained yet. Naturally, if you use Google Translate or DeepL, you won't get any unknown outputs because they're trained on millions and billions of segments and trained for days and days. So naturally, they have a lot more power than anything we would train here within 1 hour. But the output is pretty acceptable for what we have used as an input. With 300,000 sentences only in comparison and 1 hour training, we have received quite an acceptable translation, and that is just great news. So what we can do also, in case, I mean, we can see the translation here, but in case you deleted the verbose here, in case you didn't want to see the translation, you can also just check the first 5 lines, for example, of your translation. Once again, you might see different lines here than I do because of the shuffle, different shuffle. And also, as you can see, we named the translation simply translation. Remember, we decided to just name it translation, but it has automatically should have been saved to our Google Drive folder as well. So let's just check that. So we go back to our Google Drive, and now we can see we have a file here called translation. So this is great. You know, we connect our notebook to Drive once, and everything we do, if we connect it to the right folder, it will just automatically save all this data to our folder in Google Drive, and it just happens automatically. So that's a great process as well. Okay, perfect. So now we actually have our translation. Let us desubword the translation. So let's detokenize it so that we get rid of all these underscores, because clearly we would like it to be in normal, natural language. So in order to do that, we will clone our GitHub repository, as maybe you've done in the basic level data planning and collection notebook, if you've used that, or in another notebook, because within our GitHub repository, we have, so this is our GitHub repository, and here in data preparation, we have a file for desubwording. So we have code here. So this, we will refer to that code now. Then we also need to just make sure that we have a sentence piece installed, which is the subwording package that we'll be working with. And now we get to the interesting part. Remember that we have saved from the first step where we prepared our data, or if you have downloaded the zip file, remember that we have saved our subwording, our sentence piece models as well for the source and the target. And this is what we're referring to here. We're referring to the sentence piece target model that we have previously trained. We're working with target because we're working with German right now. We want to desubword the German translation, right? In this line here, we're calling the code from our GitHub notebook, from our GitHub repository. So you don't need to change anything. And what we want to desubword is our translation file. So we can just run this. And that's pretty quick. So now our desubworded translation file is called translation.desubword. This is, and we can just check it here. Perfect. So we can see these are the sentences that we have up here as well. But here they're still subworded, tokenized, and now they are desubworded. So now this is actually natural language, and we can read it, and we can analyze it, we can save it in a file, and we should have it here as well saved if we just reload it. And we can see down here, translation.desubword. So we have the file here as well. Great. Now we can do a quick evaluation, a quick quality evaluation of our translation, or you could say of the NMT model, of how well it has performed. And to do that, we need to compare it with our reference. So we translated a text from English to German, right? So the translation we received from our NMT model is German. But originally, we also prepared a German test file, if you remember correctly. So this is the German test file, which we haven't used yet. And this German test file now works as a reference, so we can compare our translation, the NMT translation that we just created, with this German test file, because this is the one from the original data set. So this technically is as good as it should be. And now we can compare our translation to that. But first of all, we have to desubword this original translation file as well, this original test file as well, because it's subworded, as you can see. And now you can see the names keep getting longer, but you can see this is the German test file now desubworded. And we can just check it to make sure that it's worked correctly. And you can see, okay, also, this is the German test file that is desubworded. And you can see already the lines are kind of the same as up here. But let's actually see how well our translation is in comparison. In order to do that, we can calculate a BLEU score, or a different implementation, the Sacre Bleu score, which will compare our NMT output translation with the German reference translation. So first we need to install some BLEU functions, some Sacre Bleu functions. That is pretty quickly done. I can just cancel this because we don't need to see that. And you can easily run this cell block now to actually calculate a value. And as you can see, we will calculate a Sacre Bleu value by calling the Sacre Bleu function. We are using the German reference. So this is the German reference, the desubworded German test. And as an input, sort of in comparison, we will use our translation. And this shows us that we're getting the BLEU score value, because you could also calculate different scores with the Sacre Bleu function that you can look at in our MT quality evaluation notebooks, which is linked down here if you're interested. There's more information on quality evaluation in this notebook. And then this shows that we are printing only the score. So we don't want to see any of the background information, we just want the score. So now you can simply run the cell, and we should get one value. It loads a bit, of course, because it is comparing 35,000 lines. So that's quite a bit. And as you can see, we get a score of 23.6. So BLEU scores are calculated or rated between a value of 0 and 100. So naturally, the higher the value, so the closer to 100, the better the quality. So it looks like it's a relatively low score, and naturally it won't be a really high score considering we only trained our model for 1 hour on a rather small data set. But if we think about it, the value is not as low, because competitive BLEU scores actually start at around 30 or 40. They are increasing nowadays because clearly machine translation systems are becoming better and better. But this is by no means a bad blur score. So this is something very interesting to start with. So just kind of as background information that this score isn't competitive, but competitive scores aren't usually aren't around 80 or 90 either. So don't think that this is a very bad score. So now, congratulations, because you have either prepared your own data or you have used the data that we have prepared for you, and you have trained individually your own NMT model using the data from scratch, and you have used that model to translate a test data set. You have desubworded that test data set, and you have quickly evaluated it by calculating a quality evaluation score. So congratulations, because that is, as I would say, as complicated as it gets. Of course, it gets more and more complicated if you want to change more parameters and different aspects, but this is really how it works. And if you know how to train a model like this, you can more easily adapt it to your own needs by using a different data set for a different language combination, or by training, maybe using the same model, the same data, but training the model for longer. There are different variations that you can now try if you would like to. And even if not, you have successfully trained your own NMT model and evaluated it. So congratulations.